Hello everybody, my name is Balint Nemet. I'm the project manager of FLEXITRANSTORE Work Package 7. Today, I would like to introduce you this fantastic dynamic line rating technology. FLEXITRANSTORE is a research and development project funded by the European Union's Horizon 2020 Research and Innovative Program. FLEXITRANSTORE aims to contribute to the development towards a pan-European transition network with high flexibility and high interconnection levels. It is promoting increased power flows using the valorization of flexibility services. Under the framework of FLEXITRANSTORE Work Package 7, the development, implementation and maintenance of a dynamic line rating-based expert system for power lines is taking place. Dynamic line rating, or DLR for short, enables the higher thermal utilization of power lines. Furthermore, an icing prevention and detection subsystem is integrated in order to forecast ice formation on power line conductors. In this video, the system implementation and operation on the Klecce-Logatec 110 kW demo overhead line is presented. The OTLM, which stands for Overhead Transmission Line Monitoring Sensor, is developed and manufactured in Slovenia by a company that is part of the CNIL Group. Weather stations for DLR system are also produced by the same company. The line monitoring sensor simultaneously measures the conductor temperature, sag, which indicates ice formation, and current of power lines. The weather station is capable of measuring ambient temperature, solar radiation, precipitation intensity, wind speed and direction. Both devices transfer the data to the central server via GSM network. The installation of the measuring equipment is simple and fast and can be executed via live line installation method without the de-energization of the power line. Before the installation of the OTLM line monitoring sensors at the demo line in Slovenia, several laboratory tests were performed. Environmental, mechanical and electrical tests were carried out on a sample device. The tests aimed to certify the adequacy of the sensor for IEC, IEEE and MIL standards. During these investigations, the sensor was exposed to extreme weather conditions. BME performed electrical tests in order to investigate the endurance of the sensor against lightning impulse, electrostatic discharge and power frequency magnetic field. To test if the OTLM sensor can be installed on an energized high-voltage power line, the live line installation was performed in the high-voltage laboratory of Budapest University of Technology and Economics. The sensor was installed on a 400 kV line at a live working training facility where the sensor worked properly. The focus of the project is on the Klecce-Logatec 110 kV line, which plays an important role in the Slovenian electricity system. It is responsible for energy transfer between Ljubljana and the middle of the country. There was an icing event in 2014 which caused several towers of this power line to collapse. Redispatching actions and ampacity control are possible on this line, which facilitate the prevention of icing events. The Klecce-Logatec line seemed to be a good choice for demonstration activities. In this part of the video, I will show you the installation of the OTLM sensors. Removing oxidation from the conductor, sensor placement on the conductor, close fixing system, fastening the sensor clamp, finally tightening the nuts on the fixing clamp. The OTLM Center is a web application developed to track, save and analyze data which are collected by OTLM devices. The monitoring, rating, adjustment and prediction software includes the real-time view of all OTLM system measurements. The field images captured by OTLM sensors are also displayed in the OTLM Center. Accordingly, the detection of icing events is possible. The BME High Voltage Laboratory's DLR expert system was developed in order to monitor the actual thermal state of the conductors. For this purpose, the real-time and predetermined line rating are calculated with an extended physical model. This model also takes the cooling effect of precipitation into account. The conductor temperature is also tracked by a neural network-based model. The ice prediction subsystem is developed in order to forecast possible icing events on power lines. For safe and high thermal utilization of the conductors, the sag clearance coloration is also tracked by the grid management system. Thank you for your attention on behalf of the FLEXITRANSTORE Horizon 2020 project.